Hello students, myself Professor Ankur. I welcome everyone for the GATE theory session on analog circuits. Today we are going to cover an important topic in OP-AMP Schmitt Trigger Circuits. Let's start with the session now. So this is our 7th session of theory on operational amplifier where we are specifically covering Schmitt trigger. So let's have a look at the Schmitt trigger first. When you look at the Schmitt trigger circuitry, the first question that will arise is what do you mean by a Schmitt trigger circuit? The most important fact regarding the op-amp is that whenever we talk about op-amp in open loop configuration, it will work like a comparator. But whenever we talk about op-amp as a closed loop circuitry, we are actually trying to use feedback. Whenever the feedback is given to the inverting pin of the amplifier, then automatically you can say the op-amp will work like an amplifier. But whenever the feedback is given to the plus pin of the op-amp amplifier IC, automatically it will start working like a closed loop comparator. So what is basically Schmitt trigger? A Schmitt trigger is basically a closed loop comparator. Now why do we require a Schmitt trigger circuitry? Because if we don't go for the closed loop operation, then we will not get the reference voltages. So the input is going to get compared with the reference voltages in the Schmitt trigger circuitry, and accordingly we are going to get the output as plus Vsat or minus Vsat. But if this is not there, the positive feedback is not there, the reference will get compared with noise. And under that situation, noise by definition is a random energy and has a fluctuating behavior. So because of this, it will lead to actually unwanted flickering of output. So to give stability to the op-amp as comparator circuits, the Schmitt trigger circuits were designed where these are basically working like a closed loop comparator circuits. So these are circuits where the op-amp will be connected in positive feedback mode. So now if you observe carefully, the first circuitry is inverting Schmitt trigger. So the input is connected to the minus pin and the output is connected at pin number 6 of the op-amp if it is IC741. So assuming it's like a normal notation, this is our op-amp with an output value VO. So there is a feedback path which is going from VO from R1 to R2 to ground, and we are getting a reference voltage that will be connected to the plus pin of the op-amp. So how do we get the reference voltage? Because the output of the op-amp will be either plus Vsat or minus Vsat. So automatically when the output is plus Vsat, the reference voltage will be Vsat into R2 divided by R1 plus R2. And the output is minus Vsat, the reference voltage will be defined as minus of Vsat into R2 by R1 plus R2. So this is what we mean by the upper threshold and the lower threshold. If you can see the waveform clearly, you can see the input swing which is sinusoidal and the threshold points mentioned clearly as upper threshold and lower threshold. They are also called as the tripping point, because after the input crosses that point, the output is either going to go from plus Vsat to minus Vsat or minus Vsat to plus Vsat. So when you look at the operation carefully, suppose if I assume that under initial situation, the output of the op-amp is going to be plus Vsat and hence the reference voltage is going to be positive, implies it is going to be VUT defined as upper threshold. So once I start my input signal and it will start rising, and once the input crosses the upper threshold, the potential of the minus pin will become greater than plus, and automatically the output of the op-amp will switch from plus Vsat to minus Vsat. And that is the reason before VUT, the output was plus Vsat. As soon as the input crosses VUT, the output goes to minus Vsat. This can be explained in the hysteresis graph as shown, where you can see the arrow pointing from plus Vsat to minus Vsat as soon as you cross the upper threshold. On similar lines, now since the output is minus Vsat, the reference has gone to negative value. That is going to be my VLT value. So since the reference has gone to the negative value, the input will complete its positive cycle, whatever was pending, and will start moving on the negative side. So once it goes below the negative threshold value, automatically the output will change from minus Vsat to plus Vsat. So this is the way whenever the input is basically compared with respect to the threshold voltages, the output will automatically switch from plus Vsat to minus Vsat or minus Vsat to plus Vsat. So this is the basic logic of inverting Schmitt trigger. Now the interesting point we need to understand here is, if you see the transition of the input between the upper threshold and the lower threshold, or between the lower threshold and the upper threshold, you can easily observe that the output is either minus Vsat or it is plus Vsat. Implies that the output is not responding with respect to the changes of the input between the threshold points, and that's a band called as hysteresis band. It is also defined as a dead zone. So that is the basic logic of hysteresis, which is going to be the potential difference between the upper threshold and the lower threshold. That is the band where the output is either going to remain plus Vsat or it is going to remain minus Vsat, which can be illustrated in the lower figure, which is looking in the form of a square. So as I've clearly mentioned, the reference value will be either a positive reference or a negative reference. So the positive reference value will be defined as VO into R2 by R1 plus R2. So the VO is taken as plus Vsat. So automatically the reference will become plus Vsat into R2 by R1 plus R2. On similar lines, minus Vref will be coming as minus of Vsat into R2 by R1 plus R2. So what you see as a hysteresis graph is basically like a transfer characteristics. That's a relation between the output and the input. So we need to understand only a small point. If the input grows beyond slightly the upper threshold value, the output will go from plus Vsat to minus Vsat. And on similar lines, when the input actually falls just slightly below the lower threshold, again there is a change of state for the output. So overall, if you observe, the output is either going to go from plus Vsat to minus Vsat or minus Vsat to plus Vsat, depending on the way in which the input is compared with respect to the threshold voltages. So this is the basic concept of the Schmitt trigger circuitry. Now, this is basically a non-inverting Schmitt trigger circuitry where you can see clearly the input is given to the plus pin. And since the input is given to the plus pin, you can easily observe that there are two resistances involved in the circuitry, R2 and R1. And now when you can clearly observe the output behavior, if you observe carefully, we are initially assuming that the output is minus Vsat. So as soon as the input starts rising and it crosses the upper threshold point, the output will switch from minus Vsat to plus Vsat. And whenever the input is having a variation and when it goes below the lower threshold point, the output will switch from plus Vsat to minus Vsat. So overall, if you observe, the input is getting compared here also with respect to the threshold points. And depending on the way in which the input is crossing the threshold point, the output will either switch from plus Vsat to minus Vsat or minus Vsat to plus Vsat. The similar impact of the operation can be shown in the transfer characteristics here, where the arrows are actually pointing the transition effect from plus Vsat to minus Vsat or minus Vsat to plus Vsat, depending on the way in which the input is having a comparison with respect to upper threshold. If you see the rightmost point, which is notified as VUT, and when the input crosses the VUT, the output switches from minus to plus. That can be shown in the form of an arrow, which is going from the minus Vsat towards the plus Vsat. And on similar lines, the transition happens when the input goes below the lower threshold. So this is the basic logic of the op-amp, where we can use the op-amp as a Schmitt trigger circuitry, which is basically a closed loop comparator circuitry. Now, one of the advantage of the Schmitt trigger is we are able to convert a sine wave into a square wave. We are also able to eliminate the impact of chatter, and as well as we can eliminate the impact of temperatures or external parameter variations which can create an impact on the output. So this is the basic concept of your op-amp working as a Schmitt trigger circuitry.